Welcome, everyone. My name is Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's event, Optimize Your Organization's Development Projects with Azure DevOps. Presenting today's topic is Tom Kinzer. Tom is a veteran Microsoft trainer and has expertise in database design, software development, and cloud computing. He has a strong career background that encompasses the healthcare, financial services, retail, and manufacturing industries. Having spent 25 years in these industries, Tom is known to translate knowledge to the real world to help employees perform at the highest levels. Now, please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Cloud Practice area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. In today's session, we will cover insightful understanding of Azure DevOps, from the suite of tools available to the best practices and use cases, which supports a collaborative culture and set of processes that bring together developers, project managers, and contributors to develop software, allowing organizations to create and improve products at a faster pace. In addition, participants will get guidance on effectively preparing for the AZ900 and AZ400 certification course and exam in today's session. And now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handout section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early, and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey, Tom, thank you so much for joining us today.
Well, hello, everyone. This is a masterclass for Optimize Your Organization's Development Projects with Azure DevOps. It's a long title, but the gist of it is you're going to learn about Azure DevOps, and we're going to see how to optimize your development projects with it. My name is Tom Kinzer. I am a certified trainer with Microsoft, and this is being brought to you by netcom.learning or netcomlearning.com. So be sure to visit that. You'll see that link there at the bottom of the slide. So let's get started. What is DevOps? Well, you probably have heard a lot of hype about DevOps, but there's also practical applications of the concept. And here's a good way to remember it is DevOps is the union of people. And that's first and foremost because we have to collaborate as a team, not whoever's, processing or delivering what we need to get out to the customer, but the customer themselves and the stakeholders. Not just people, it's a process. What is the overall process of how to get this done as efficiently as possible? And of course, the products that we are trying to deploy. So the union of people, process, and products to enable continuous delivery of value to end users. And that's not just some unusual wording there. It is very important to remember that word continuous. And we have a diagram there on the right that shows that it's the infinity symbol to start with because it never ends. And it's continuous integration, the continuous delivery, continuous feedback, continuous security. All of this has to be constantly looked at and reviewed over and over with the idea that we're going to deliver value to the end users, the stakeholders, the ones that really need the products that we're trying to get to them. So if you look at the slide, the diagram on the right, you'll see that outside of it, it's encompassed between collaboration and collaboration. So it's all about communication and working together. Start at the top, we plan, we build, and we may go back and forth with that quite a bit until we decide it needs to be integrated with existing code or existing environment. We deploy, we operate to see how it's working, and we get feedback. Don't forget the feedback. Every step of the way, we need feedback. Developers get feedback when they're trying to build code. They get runtime errors when they're testing it. They get syntax errors when they're typing. That's immediate feedback with the product that they're using. But that's only the beginning, because once we start moving through every one of these other stages, we need to remember to get feedback all the way from the customer, the end user. Is it what they asked for? Is it what they need? Are they actually using it? How are they using it? Etc. So that's the gist of it, that we're going to focus on continuous delivery of value. If you want to reduce that to just those few words, you can keep the foremost points in mind: continuous delivery of value. So how do we do it? What are some of the goals of DevOps? Well, first of all, it's an iterative process. It's one cycle after another, after another, after another, and it needs to be as short as possible. Even if we're not delivering much to start with, we will eventually. And with every cycle time, we want to figure out, did we learn anything? Is it going well? Is what we did the right thing? Is it good? Or if it's going to fail, we want to know early. So every iteration, we need to review what we've done, what was done wrong, where did we miss the mark, correct it, and do it again, and do it again. We also want to stay what's referred to as data informed. We want to be taking measurements of what we're doing. Is anything better? Is anything worse? For even to determine what's better or worse, we need a baseline. So before you even start your first iteration, your first cycle, where do you stand? How fast is something working now? How often is something working now? How often do we have problems? We want to strive for validated learning. So that's why we have to constantly look back over what we have done, validate what we think we've learned, and make sure that the stakeholders and the end users are involved. All the while, we're trying to shorten the cycle time. Traditionally, it takes quite a long time to get software out the door, or anything that you may be building. It doesn't have to be even coding. But in the past, decades ago, you were doing pretty good if you could get something out within the year, and really going well if things could go out within a month. But we want to shorten that even further. We want to deliver value as often as possible. Even if it's daily, if that's possible, we should be focusing on that. So we want to make sure that we're constantly trying to shorten the cycle time. Don't get comfortable with the cycle time, especially if it's just once a month. It can be much better than that. And here we have validated learning again. We want to optimize. If we're not learning with each cycle, we're probably not getting the right measurements, the right metrics to see how well we're doing. The bottom line is we always need to deliver value. The value can be very, very small at first, very limited, but we know that in the long run, with each cycle, the overall cumulative effect of multiple cycles will deliver more and more value. This also manages the expectations of your end users. They can expect more and more. If you only delivered a little bit of value once and then waited 3 months or 6 months, they will definitely lose trust in you. They'll lose faith in the process. So we want to deliver value as often and as quickly as possible, nonstop, continuously delivering value. No matter how small, we want to make sure that they can see and expect more and more value over time. And that's the only way to build the trust that we need in order for someone to trust the cycle that we are building to get them what they need eventually. So managing their expectation is a big part of this. We're going to say that we can't give you everything at once, but we will give you a little bit at a time, and we will learn from what we've done each cycle so we can adjust as necessary. So the two main phrases that you will hear when someone talks about DevOps is continuous integration and continuous delivery. These are two separate processes that overall they can be connected back to back, but we don't want to make sure that this is just a single process because continuous integration usually happens far more often than continuous delivery. And the reason for that is that's when you discover when code may not work or when integrating with other existing code may not work. So the ongoing merging and testing and merging and testing and merging and testing goes on all day long between multiple developers or designers. And the reason is we want to fail early. We want to find those defects as quickly as possible so we can adjust, fix the code, try again, try again. Once we get a successful integration, then we could consider our first continuous delivery. Now, continuous delivery, remember, is about delivering value to certain targets or environments. So notice the description here, it says deploy software solutions to testing, staging, and production environments to help discover issues and respond to changing business requirements. Notice this is not about testing code, it's testing the entire solution and whether it is acceptable to the end users, the stakeholders. So we test it to make sure it's what we expect it to be doing. We stage it with as close to production as possible and let the stakeholders decide, should we continue? Should it be approved? Should it move on to the next stage? Now you can have multiple stages or environments that you may be deploying this to. It could be geographic. We may want to deliver something to one part of the country or maybe across the globe to Europe or Japan, whatever it is. We can set those up as different deliveries. But notice in the diagram, the only thing that you can read is there are triggers and feedbacks and approval. So as constantly as we need to be delivering, we're usually delivering to a testing or a development environment so we can find out, first of all, does it look okay before we affect any other environments? Then move to staging, and if it's approved for that, we can move to the next one. If it's approved for that, we can eventually get it out to all of production or to the entire target audience. So keep this in mind that continuous integration and continuous delivery are very important, but we've got to make sure that you focus on continuous integration first and as often as possible. It could be as much as 10 to 1. You try to run continuous integration 10 times for every successful one, then you might use continuous delivery. But you don't have real DevOps until you can do both of these automatically. As long as you're relying on manual approval, then you may only have continuous integration, but not continuous delivery. We also must have version control. In Azure DevOps, we can support what's called centralized and distributed version control. Distributed is far more popular now and much easier to work with in a distributed remote environment where we have developers working from anywhere. And if it's distributed, the most famous or most popular one is using Git. And in Azure DevOps, you can choose Git for your repositories, and that would introduce branching. As we see in this diagram, we can create as many parallel branches as we may need to focus on the changes and the code changes for each individual feature. Once the feature is considered to be ready to go, and we've had a couple of other developers look at the code with what's called a pull request, then we can approve it to be merged back in to um, another thread or branch when we're ready, because now we can see how it works within that other branch. So in this example, very simplified view here is that the main branch is where production resides. So any state in the main branch indicates the state of production. So we don't want to move feature one, for example, that's indicated with orange up into the green until it has been tested. So we need to have several people look at the code, say it's okay, or even test it before it can be merged back into the main branch. Feature two is the same thing, and they can be done in parallel. But we have many features that may be going on at the same time. We may even have a hot fix. It would be rare if you only had 3 branches like shown here. It's much more likely that you have a state of 5, 6, 7 different branches at least going on simultaneously. But version control is going to let you keep track of the different versions so that you could roll back if there's a problem. The branching is a feature of Git. And because it's a distributed environment, we are always trying to commit and merge features together so that we can see what all other developers are working on. And eventually, of course, push it out to main. Now, whether you're using Agile, Lean, Kanban boards, Scrum, all of these are supported in Azure DevOps. In fact, there's quite a bit of overlap between the four, but you will rely more heavily on boards to indicate the status of your work items as they move between different statuses like new, to do next, in progress, ready, whatever you want to categorize the state of every work item, you can set up your Kanban boards to do that. But you do want to make sure at the very far right of this board, you see that it has a done column, which means it has been completed. But definition of done is that the working software is meeting what the requirements state and it has been released. It is ready and gone out the door. So next cycle, it would not be on your board anymore. It would just you'll just have new ones moving from left to right across your board, with everyone who's working on it able to change the state of where it should be next. And all related work items, such as tasks, say under stories or requirements. Then once we've deployed it to a certain environment, we need to be able to monitor what's going on. So you need a way to monitor, audit, log all the events that may or may not have a direct effect on the responsiveness of the application. So you will know even before users may know that something is trending in the wrong direction or in the right direction. We also can use DevOps not only to deploy on premises, but to the cloud as well. So DevOps supports both public and hybrid clouds where it can be in a cloud or privately within your own network. And has made this much easier because the cloud just becomes another environment of where to deploy your code and your solutions to. This also makes it possible to define your infrastructure as code, especially in the cloud, because we're not dealing with any real physical machines. Everything we're doing in the cloud is virtual, whether we're talking about virtual machines or services, virtual networks, all of that can be defined through code. So now we can move into an area called infrastructure as code, where we can even daily destroy the infrastructure and rebuild it if there's any major change, or maybe you just do it out of practice that you want to recreate it on a regular basis. So it allows you to automate and validate total environments, completely new environments, geographically or just for different purposes. So the only way to do that is to define your infrastructure in code, whether it's through scripting or templates. And so Azure DevOps makes that possible because your infrastructure as code also gets loaded into version control. All the definitions of servers and networks and databases and the structures and options and configuration of all of that is all done in code. So we can rely on the repository within Azure DevOps to not only define the solution, but the infrastructure it needs to run so we can completely rebuild everything from scratch. Now, there's also been lately a push toward breaking applications into smaller and smaller reusable components called services. So DevOps makes it easy to start moving toward microservices because we can treat those individual services as deployable units. So instead of always having to deploy a monolithic or layered architecture, we can now start focusing on deploying smaller and smaller pieces that are independent of each other, even though they may leverage the services of each. We now can greatly speed up your cycle in DevOps by focusing on just the individual microservices. So implementing microservices is a goal that many organizations are considering, and DevOps is making that much easier. And also, if you're also moving to containers such as Docker images and Docker containers, Azure DevOps makes that also very easy to move those images or containers into many of the Azure services that support those containers. So instead of using or building traditional web applications, for example, on a web server, we would break down those applications into very smaller and smaller microservices that do one thing and only one thing really well, and they publish their interfaces so that other services can leverage all other services. This is a completely new type of architecture, though, if you're coming from a monolithic layered application. The classic client server or client business data service layer is being replaced by microservices. Now, not every solution fits microservices, but also there is no need to immediately move off of monolithic, but it's a goal to keep in mind and another alternative uh, to building only monolithic applications. Because the downside of monolithic apps is that you have to deploy everything every time. If there's a strong dependency between these layers, one change in one will affect all the others, so they all have to be updated before you can deploy. So that slows down the cycle because so much has to be done just to accommodate one simple change. So microservices is a worthy goal. It may take quite a while, though, to break down your monolithic applications into microservices, but it can be done over time, gradually, as you start tearing apart your monolithic applications and trying to create services with each cycle or with multiple cycles, focusing on what can be defined as a microservice and also be deployed or delivered within its own cycle. For all of this to work, though, DevOps must be clearly defined projects, and they must have measurable outcomes. Now, sometimes we don't have a problem with clearly defining the project, but we do have a problem sometimes is, well, what are we measuring to determine if something is better or worse? And if it is, one way or the other, how much more? So using a percentage and a unit of measure of some form, we can have a clear goal set as to what we expect to happen and what we're focusing on. And notice these bullet points. These are examples. Reduce the time spent on fixing bugs. Well, before we even read the rest of it and by how much time do you spend on fixing bugs now? There's no way to answer a difference if you don't even know what time you're spending on it now. What about unplanned work? Well, how much time is spent planning, working on planned work? So, and then if it's measurable, you have to say, well, what is the improvement? Well, by 60%. So we're going to reduce something by a certain percentage, means we have to have a good record of what it is. And then the fourth one is remove all direct patching of production systems. Well, that should be probably the top of the list, because by using Git and using branching, we can make sure that we do not affect production without going through a separate branch. Even if it's a hotfix, we would have a branch for the hotfix to see if it's working before we merge that patch back into production. And what we're trying to do overall is we're going to provide greater customer value. Greater means you know what it is now. It may be great or good now, but if we want to make it greater, you have to measure what you already have. That baseline is very important, because you have no idea how much better or worse something is if you don't even know what that baseline is. So outcomes should have customer value focus. In fact, the customer should understand this clearly defined outcome. What does it mean to them? It could say, well, the response time of this system would be improved by 50%. Well, is that measurable right now? How long is it taking now for some single transaction or an event to occur? Does the customer agree to what it is right now? So even before you start working on anything, before you provide any new value, you need to take inventory of what you have before you address it, especially measurable outcomes. All right, so that's just one, shared goals and defined timelines. Number two, there should be timelines that are challenging yet achievable. Now, that's also pretty tough to clearly define. We don't want to create a goal that's very challenging and impossible. We want to see what is possible and how quickly we can address it. So what can we accomplish within 2 weeks or 1 week or 1 month or 3 months? And that's not easy to do until you know your staff, till you know what they're capable of, and also prioritize the goals that the business users expect and the stakeholders. Notice the third point. Timeline should be a constant series of short-term goals, each clear and measurable. And the fourth one, shorter timelines have advantages. But first of all, I want to point out that all three of these have the word timelines in it. So if you're working with Scrum or Agile or some other process, these can relate to what are called sprints. We establish a fixed series of sprints, and each one of those have goals. So those are acting as short-term goals that are clear and measurable. And that allows us to adjust what needs to be done per sprint. We're not going to talk about in specifics, the definition in Scrum and Agile, but I want to correlate those words so you can see how this is important with Azure DevOps. Your constant series of short-term goals are built around a fixed timeline. Now, if you have projects in your organization where one project has its own cycle of, say, 3 weeks, and another project has a cycle of 8 weeks, and another one has 2 weeks and 5 weeks, no one will ever understand across the board what is your constant series of timelines, because everybody's is different. So for that to be clear, it's highly recommended that you have one set of timelines for everyone. So whether that's a 2 week or 3 weeks or 1 week or whatever, make sure that it's fixed for everyone. So a common fix for most people is 2 weeks, and we refer to that as a 2-week sprint. So every 2 weeks, we know that we're starting another cycle. Now, that means, though, you have to set the goals for that 2-week period. And that 2-week period needs to be very clearly understood that this is all we're working on within this 2-week period. And anything new that comes in, we have to think about, is it serious enough that we have to put it in this sprint? But more than likely, it's going to be planned for the next sprint or the next time series. So the short-term goals can be shifted, but the time should not be changed. We always can say, well, that can be moved to the next sprint or the one after that, unless something super critical comes up, but then you now have to discuss what has to be pushed out of the current timeline because we don't have time to do it. So that's the whole purpose of fixing a time period, is that we need to be able to change plans and priorities from one period to the next. We also want to get immediate feedback every cycle. And everyone understands that we're in a sprint review, or whatever it is, a retrospective, whatever terminology and process that you commit to, make sure it's consistent, constant, and it has very clear, measurable outcomes. Positive at that. Nobody wants negative outcomes, but we want to focus on producing positive outcomes, improving something. So that's really the goals of DevOps. So what does Azure DevOps bring to the table? Well, here's some of the primary services in Azure DevOps. We have Azure boards, pipelines, repos, artifacts, and test plans. Now, there's no priority to the order of this list. It's that normally you do start with boards if you're going to use any type of Kanban boards. You may only use repos. You don't have to use pipelines. You may use artifacts built into Azure, or you may use other types of package feeds. So there's no requirement that you have to use all of these in any combination. In fact, you could implement some of these much later, like test plans. You may not need them immediately, so you could focus on some of the other services, and then start adapting, or maybe taking advantage of as many of these in Azure DevOps as possible. The reason I would recommend that you use most of the services in Azure DevOps is they're already tightly integrated. You don't have to worry about trying to import and export constantly between different types of tools, especially third-party tools, and also multiple types of authentication and authorization. But there's also no need for you to have to switch everything to Azure DevOps. You can continue to use processes that you've been using for years and still take advantage of other services in Azure DevOps. So let's look at each one of these. First of all, boards is for planning, keeping track of your work items. The Kanban boards, where you can shift different work items from one state to the next. It allows us to visualize and to collaborate on who's working on what and when things should be done. And then the pipelines are going to actually go through different steps or activities to perform jobs, whether it's for continuous integration, or it's for continuous delivery, or both. So we have pipelines to make sure that certain activities are done in a certain order, and that we're testing and setting up what are called maybe quality gates or release gates in a CD pipeline. Whether we're pushing it out to a particular platform, or whether we're working with raw code or containers, or moving out to Kubernetes, on premises, any combination. Repos is our source control. The Azure repos typically is Git. It doesn't have to be Git, but when we're talking about repos as well as branches, then we are talking about Git. So it's probably now more often than not, everyone is choosing the Git repo, which is where we push our code to. We pull code from it, work on it, push it back, and that's the whole process of creating branches and committing to those branches in different copies. And also where we do pull requests, where multiple developers will review the code before it gets merged into another branch. Now, what we build with our pipelines is either going to produce an artifact, or it's going to consume an artifact, or both. So Azure Artifacts is a holding area for whatever we may create or what we may need to reuse, coming from many other types of package feeds, from Python to NPM, etc. And then last on this list, and definitely not least, is how do we test what we're doing? Now, this doesn't mean this is the only place to test. We should also be testing in our pipelines. So pipelines are performing testing. And if you're doing most of your upfront testing of code and what's being produced across your artifacts, your test plans are going to provide much more depth and much broader ways of testing the solution in a particular environment. So test plans are very helpful in integrating testing directly within your application and in your solution planning. So let's look at examples of each. The Azure Board. Here's an example of the Azure Board. Across the top, we can see how it may be labeled. We've got new items on the left. We also have across says doing, done, doing, and done. But notice these are under different subheadings. Design, and let me circle some of these. You can see what I'm talking about. So we have new here, we have design, and then we have develop and test, and then we have our definition of done, of when it actually gets deployed. But design is broken into two, doing and done, develop and test, doing and done, and only if these are all complete is the entire work item done. So as we bring into scope, maybe within the current sprint, we can say this is going to be a new item for this sprint. Or it could be simply backlog items that we haven't decided what sprint they're going to be part of. And then we can move it to here, and then move it to here, and move it to here, etc. So it moves from left to right across the columns, so we can keep track of at any point in time. We can look in here to see the status of different work items. Now these work items will have different types. These types are going to be based on the process that you want to follow, whether it's agile process or the scrum process. So you may have work items in here called tasks or stories, requirements. Whatever terminology you're already using now can be incorporated directly within these Kanban boards, or you might want to take the time to adapt a new terminology with your work items. They could be issues, they could be bugs, anything associated with your project that you would like to label as moving between different states is how you could track this with a Kanban board. And you want to make sure things are constantly moving. And also, one thing that's very common that you have to avoid, being very careful that you're not just a term that we use, maybe it's just an American term, but kicking the can down the street means we're never really doing anything. We just look at this list and say, okay, we didn't do that this sprint. Let's just kick it to the next sprint. And then the next sprint comes along. Nope, we didn't do this again. So let's kick it to the next sprint. So if you're never actually addressing the problems, what's the point? There's no need to even have something like this. Don't pull anything into your Kanban boards that cannot be done within the sprint that you're currently in, which brings up another concept, and that is backlogs. So notice there is a separate area to keep up with your backlogs. These are things that should be done eventually. We just don't know yet when, maybe because they haven't even been reviewed. No one understands yet what they mean. They need to be fleshed out. They need to have some type of work effort estimated on it, and then they need to be prioritized according to the stakeholders or anyone who's driving this change. Which one should be done first? And until anything is prioritized, you really shouldn't pull it into a sprint. So be careful that you don't use boards as your backlog, but only boards should be used as a way to keep things moving. And one of the main reasons you have a daily meeting, a very short daily meeting, is you ask each person, where are you on this or that? And they're going to tell you what they did today and what they plan, or yesterday and what they plan to do today. And if there's any problems with why something can't be done or move between these stages. So the boards help you keep track of this. Is anything actually happening? Is anything moving toward completion? Are we getting anything done, from day to day? So boards can be very useful ways of collaborating as a team. And keep in mind, you want your stakeholders to have access to this, even though they may not be able to edit it or change anything within the Kanban board. If they're not affecting these work items, they need to still be able to look in here and see what is it that's being done. Oh, one other thing. You also can put a limit on what can be done within your sprint. And that limit, as you see in each one of these, is saying we can only do 10 design tasks per sprint or 15 develop and test work items per sprint. So notice this is saying 5 of 10, 4 of 15. So we haven't maxed out our capabilities for the sprint or the time period. So we're not, and we want to pay attention to that because we never want to go over it. And we also want to make sure that things are being done, and we're hopefully we have 0 at the end of the cycle, that everything has been moved into done at the very far right. Now, if something cannot be done within 2 weeks, it needs to be broken up. So we need to have multiple tasks, multiple stories, multiple work items to cover what can be done within our sprint periods. The biggest issue usually with work items is they're oversimplified, they're too generic, and they're too big. So a lot of work has to be put into getting these work items into bite-sized chunks, something that can be chewed on and consumed within your sprint, one sprint. All right. So where do we keep up with the code? Well, Azure DevOps supports both Git and TFVC. Now, TFVC is actually the original version control that was in Team Foundation, which was the precursor to Azure DevOps. So TFVC was a centralized version control where you had to check out code and check it back in so you can control basically through security who has access to what piece of code, who can change it, and you can't work on it until it gets checked back in. So that can be very useful for the large project where you want to control who has access to what code. But Git does not do that. Git lets you have the entire copy of all the code at any one time. So every developer gets a full copy of everything on their local machine, and they can make adjustments to anything that they have a copy of. And then they can commit it back to a branch. So the way that changes are controlled with Git is not checking out and checking in, but cloning the entire repo and then merging it back in to a particular branch. This gives all developers access to all code at all times, but it doesn't have to be accepted when someone merges it back. In fact, pull requests are a critical part of managing source code in that at least one other person, two other people, need to review the code and approve it before the code from one developer can be merged into a parent branch. And so that becomes your code review that you can make fundamental and required before it can be merged into a particular branch. That should always be required for the main branch. Other branches, that'll be your option as to whether it would be appropriate for pull requests or not. But anything that affects production really should require a pull request and approval from at least two people. So the first question when you move to DevOps is, are you ready to move to Git? If not, then you may have to stay with TFVC for centralized, which doesn't support some of the concepts that are in Azure DevOps because Azure DevOps features are generally built around the concept of Git. But it still works, primarily for backward compatibility with the original design. So what's the best practice for source control? Make small changes and commit them often so that you can see how well they integrate with what other developers are doing. And even if you don't have many other developers, it gives you an opportunity to test gradually for every change that you make. Do not commit personal files. What does that mean? Well, you could have some files within your project that may have sensitive data in it, or it may be test data that's irrelevant, to certain environments. And you definitely do not want to push that into a source control where it becomes a permanent part of your repository, and everybody gets a copy of it when they clone it. So make sure you have no sensitive or personal information in any of your projects. Do not commit personal files to source control. There are other mechanisms for that, but don't use Git for that. Update often and right before pushing. So that goes right along with make small changes. Make small changes, keep it light, keep it small, and update as quickly as possible and as often as possible. And the reason you want to do that is that you will not conflict with anyone else that may be committing to the same branch. And when you get to the point of merging it, the least you have done, the less likely there'll be conflicts, but the more often you can do it. Verify your code change before pushing it. Well, that seems kind of obvious, but sometimes you don't. You make a change and you push it and you go, wait a minute, did you save it? Did you test it? Did you compile it, and test it? So sometimes you can get in a hurry and forget that. So that best practice is don't forget that. Also, when you commit, you should enter a message that clearly defines everything you've done. And if you keep it small, then your commit messages will be short. Don't do too much at once. Like you could go all day and not commit anything to the end of the day, and then what are you going to say you did? It'd be a whole, paragraph of things. So every time you do one unit of change for one purpose, commit the code, and that will be recorded in the repository. Now, when we talk about repositories, we're not necessarily talking about the one in Azure DevOps yet. We're talking about your local repository. So every time you clone something, you're creating a copy of that repo to your machine. You commit to your local copy often, and then once you get to maybe a point settled by the end of the day or maybe a couple of days, you have many commits in your local repo, but then you merge it into a branch. Those commit messages go with it so that anyone can look back over every change you've made locally as part of the repo that you finally merge it into. You're trying to explain to other developers why you made the change. What was the change made? Number 6 is a big one, and this only happens if you use both the boards and the repo in Azure DevOps. Now, there may be third-party tools that allow this as well, but it's much easier to link your code changes to work items. Number 6 is when you commit, you can indicate which work items that you have worked on so that it can be automatically recorded with your work item. And the last one, this one can be tough for people that have come in new or they've worked with different practices, different policies. No matter your background or preference, be a team player, follow agreed conventions and workflows. Now, that may mean breaking old habits. Maybe you came from an environment where there's very few pull requests, and then now you're being asked to do a pull request every time you merge to any branch. Or maybe there's far more branches than what you're used to, or the opposite, it may be far fewer branches than you're used to, and you have to be even more careful. There will be differences in conventions and workflows, not just from organization to organization, but from team to team. Try to find out, what does the team expect? What have they done over the past? And try to cooperate with those conventions. Now, that doesn't mean you shouldn't question it, because in some organizations, you have what's called a retrospective meeting. Like, what should we stop doing? What should we keep doing? And what should we try to do as a new process? Those opportunities should always be there, but that's when you can bring up, well, it would be good to do so and so because of so and so. So do try to follow agreed conventions and workflows, especially if you're new to the team. But feel free to you should feel free to suggest other ways of doing things. Now, since we're working with Git, it is distributed, so it has its pros and cons. The strength is that we can use any platform, any language, and still, even work in the same repo. It is open source friendly because it allows you to bring in not only artifacts and libraries that were open source, but you can build your own open source solutions that could be republished to an open source um, repo for others to use, not even in your organization. The third one is the biggest benefit to me, is that it's complete offline support. You get the entire repo. Everything gets downloaded to your machine where you're working, so you're never having to worry about someone has part of it locked out or not. You can see everything that's going on. Now, it also has portable history. You get a copy of all the history. Now, that can be a downside because for any project that's large, it's been going on for decades, there's a tremendous amount of history. But with Git, you can truncate history to a certain point in the past, but at least you'll see everything that's been going on, depending on the level of history that you want to keep. It is definitely a very popular, enthusiastic, growing user base. Now, it's best used for, now here's where a gotcha is, smaller size modular code bases. That means it works really well with microservices and works well with small components of solutions. But it's not usually the best choice if you're coming from a large monolithic application, which most people are. So that's where the catch-22 is. Do I have to create microservices or modular code bases before I can use Git, or can I use Git on monolithic apps? Well, yes and no. You have to find that right balance because some monolithic apps will work just fine within Git. Others may not because how their enormous size. So you may have to stay with a centralized source control until you're able to port that monolithic app into more modular forms or more modular code bases. Now, this does not mean you have to move everything to microservices. You just have to break it down more and try to make each part of the monolithic app more independent of all the other parts. So some of the names for this are not just Git. We have Mercurial and Bazaar and maybe some others that are distributed source controls, but Git is by far the most popular. Now, if we focus on Git, we know that we've already mentioned that you're going to have to get accustomed to feature branches, or you can just call them branches. Most likely, a branch is created because a new feature needs to be developed. And it could be that 3 or 4 teams are working on the same product, but different features. So every team may end up with their own branch. And then ultimately, that feature will be either ready to be deployed or not. Now, keep in mind that features do not have to be completed in 2 weeks. They could run for months. But the longer they run, the more likely they're going to have conflicts when they get merged back into wherever they came from. So even though features are not intended to fit within a sprint, everything that comprises that feature is composed of, like hundreds or thousands of lines of code, those sections of the feature, each of those pieces of that feature need to be completed, each one within a sprint cycle. But overall, it could be that it takes 50 or 100 work items to completely define a feature. So don't confuse branches with a sprint. A branch is the source code itself being broken off into parallel from the original production or any other environment for as long as necessary to fully define that feature or what the branch is intended for. And then at some point when it merges, it will eventually be part of a release. Now, since Git is distributed, everyone gets a copy of a repo. So that's why you see the second box here, full repo for everyone. Pull requests means you need someone to review your changes. So a pull request means you, as a developer, are requesting others to pull your code. So they need to drop into your feature branch. They need to see what you're trying to merge in, and so they will review it and either approve it or deny it. And this is a great opportunity to start introducing, especially new developers, to standards and policies that even though it may work, that's not how we should write it. Or you're using a technology that no one has seen before, or they know there's better ways of doing something. So the first couple of times you do a pull request may be a very slow process. It could be very painful, but those should get faster and faster as well. Remember that this is designed for distributed communities, and especially over COVID, where everybody was working from home, Git worked really well. But it's already been pretty well established before then, but it proved to be very compatible with the lifestyle during COVID, and that is everyone worked, anywhere and everywhere, mainly from home, and we could all get our own copy of all the code necessary for a particular solution. And then we coordinate all of this, these changes and these merges with our release cycle. In fact, you may create a branch just simply called release, and that you work on a release that will eventually be merged back into main. But that doesn't affect your cycles. The cycles are still going to keep happening, say, in 2-week periods. So whatever that 2-week period comes around, only what has been merged into main will make it out. Sometimes there are no changes to main, but you still go through that cycle. But it should be an alert that you need to review it and say, well, why didn't we get anything out? from 2 weeks to 2 weeks to 2 weeks, you should be distributing something, even if it's a cosmetic change or a very simple change. That can be broken down into a specific feature, maybe made up of multiple work items. At least the work items should be deployed, even if the feature is not completely ready. So don't confuse features with releases and branches with releases. Branches are simply to manage source control. They should be synchronized in such a way so that when you do eventually merge something to main, that it will go out with the next release. All right, so here's a typical workflow. We create a branch for a purpose. You also name it based on that purpose. Like if we're trying to add a new page to a website, that should be your branch. Add new page to website, or be specific about what it is. Maybe it's an admin page. Add admin page to so-and-so website. Then we start working with it. And when we created a branch, we have now been separated from the branch it was created from. So we only commit to that new branch. So add commits over and over and over again all day long, maybe by 10 or 20 different people. When you're ready to say that what I've worked on today is ready to be merged directly within the branch, you open a pull request, which invites others to say, okay, we need to discuss and review this code. And they will approve it or deny it. So if they do approve it, then we deploy it. Now, where do we deploy it? Well, it's where are we going to merge it to? So if we have a testing environment that we need to deploy first, like your own local machine or a shared environment between those who discussed and reviewed the code, or maybe it's a QA environment, then you can merge it to the next stage, whatever that is, the next uh, branch. So it gets promoted up into a higher and higher branch, eventually production. Notice it says you're going to share a feature without touching any official code. The only time you touch official code is if that final merge is back into main, and no developer should ever merge into main. No developer should merge into main. I can repeat that again because in small shops that seems impossible. And in shops that have been doing it for many years, they go, what do you mean? Of course, my code, I can merge into main. No, because when you start merging into main, you're affecting production. And that becomes more of an operational feature than a development feature. So be very, very careful of assuming that you're going to merge all the way up. Only someone who has that final authoritative position where they can say, well, I can trust that everybody has reviewed their code. They maybe merge into a release branch, but it's only when we're ready to get that release out would we merge it into main. Main should always show current code that's in production. So when we do pull request, that means we're first of all on a separate branch. And on that branch, we do a pull request so we can review those changes. You're basically announcing to others that we can review it, discuss it, and only if it gets approved do you merge it. If it doesn't get approved, then you got to get back to coding and committing more, and then you ask for another pull request later. The reason for this is we want to discover problems as early as possible. We want to be able to address those problems. And we're trying to also address what's called technical debt. If we don't focus on quality, we will end up having to pay for shortcuts. Notice this definition that technical debt describes the future penalty that you incur today by making easy or quick choices in software development practices. That fits so well with financial debt. I got to have it now, so I'll put it on a credit card. Doesn't mean you never have to pay for it. Same thing happens in code or in a configuration of applications. I need to get this out the door, so I'm going to take a shortcut. I'm going to bypass something I know I should do, but I'll do it later. Well, eventually it never happens. It never gets done. So technical debt always is accumulating. And just like with financial debt, it has compounded interest. It gets harder and harder to pay off that debt. We must use automated testing to measure technical debt. And there's many third-party tools that can do it. Because if we don't, it's going to add problems during development. It's going to be making it much more difficult to improve things. It actually, once it builds up to a certain level, it's just overwhelming. It frustrates development teams because they feel like all they're doing is fighting technical debt, and that's a common problem. So, but it doesn't mean it should be allowed. We need to fight that tendency to incur technical debt. It makes code harder and harder to understand, makes it fragile. It also increases the time to fix the problems and to validate those problems. It starts small and grows exponentially, sometimes compared to a snowball rolling down a hill. You only have to start with a very small snowball, roll it, and it accumulates more snow faster and faster. Use automated testing and assessment to locate, identify, and address your technical debt. And I can tell you up front, it's going to be overwhelming. You're going to be totally surprised, maybe even blown away, of how much technical debt you may have. Use tools that can help you find it. Here's two that are mentioned. You have Independ, if you're using Visual Studio, and it can assess how bad your technical debt is. It can help categorize it and also show you some of the most critical changes that need to be addressed. We also have ReSharper. ReSharper can analyze your code and tell you where you may have quality issues. These are just a couple examples that can be included in Visual Studio or be part of your continuous integration pipeline. Then we talk about pipelines. Pipelines are basically the concept of a series of actions that need to be done so that you can automatically build your code into components. You can integrate it into existing environments, and then you can test it. And if all that is fine, then you can deploy it. So in Azure DevOps, we use the term pipelines for both CI and CD for continuous integration and continuous delivery. It's a constant flow of changes and activities that should be always easy to trigger and constantly producing some type of result so we can keep track of where our changes are. They need to be repeatable, reliable, and designed in such a way that they are keeping us in the loop and giving us feedback of what's wrong and how to improve it. And we also are going to have to run the pipeline somewhere. So pipelines must have infrastructure, and the infrastructure that runs that pipeline must be, of course, exactly what it needs so it can be effective and run as quickly as possible. So in Azure, we have this concept of pipelines as a cloud service. Now, even though it's in the cloud, it can still build and test your code that may be on premises. It works with continuous integration and continuous delivery. It works with the most popular languages that you may be using, such as any .NET language, Python, Java, etc. You also can target multiple environments within the same pipeline. You don't necessarily have to have multiple pipelines for every target, but that's your call if you want to. It can integrate with what is already available in Azure, whether we're pushing out to Azure App Services, Azure Kubernetes Service, container registries. It could be infrastructure such as virtual machines, virtual networks are very easily integrated within Azure. It can work with multiple operating systems, Windows, Linux, and Macs. It can also integrate with another service from Microsoft called GitHub or other Git repositories. And it works with open source projects, just like GitHub does. So this is probably the first mention of GitHub and the only mention that I'll probably make in this class or this presentation is that GitHub has some very similar features as Azure DevOps, but it's been around longer, and Microsoft acquired GitHub several years ago. So the jury's out as to how Microsoft is going to keep those two services in parallel or which one may get unique or special services the other one may not. So pay attention to GitHub and Azure DevOps as they are developed in parallel. Excuse me. All right, we've been at it a full hour, so let's take a short break, and we're going to come back and look more specifically at different terms that you need to be aware of in Azure pipelines.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Welcome back, everyone. Let's continue with our topic now. All right, so Pipelines is a cloud service running in Azure DevOps. It's going to support both continuous integration and continuous delivery with two separate pipelines. Again, works with different languages, different platforms, different operating systems, etc. Terminology that we need to be aware of when we're working with pipelines is that a pipeline is made up of stages. A stage is made up of jobs that require agents, and then the jobs are made up of steps. These steps can be individual scripts or tasks that perform some specific role within the overall process. Every pipeline is started by a trigger, whether it's scheduled or it's waiting on an event to happen. These pipelines can support both continuous delivery, continuous integration, of course, it usually happens first. And then when you do deliver, you are usually focusing on a deployment target. When you run the agents, they can only be either Microsoft hosted or self-hosted. It's easy to start with Microsoft hosted because you don't really have to do much except indicate what type of agents you're going to use, and Microsoft will automatically spin them up, they will provision them, and will run them. Because of this, it's much easier because Microsoft is going to do all the maintenance and the upgrades for you. So at first, it sounds like that's the best way to go. However, it's very slow startup because they have to be created every time. Self-hosted takes a little bit more work because you own or you manage the maintenance and the upgrades. You have to specifically set up the machines, but the trade-off is a much faster startup time, and so your pipelines overall will run faster. So eventually, you probably want to make every one of your agents self-hosted. Until you're comfortable with what they really need, you might want to rely on Microsoft hosted just to test and get things going, but eventually switch over to your own self-hosted agents. And self-hosted agents can run in the cloud as well as on premises. When you set up a machine that will act as a hosting environment for an agent, they can then be logically pooled together so that when your pipelines run, you indicate what pool each job requires. These agents can be associated with different pools regardless of what machine they run on. So in this example, we see we have 3 agents on one machine, but we only use 2 of them in pool A and the other one in pool B without having to set up another machine. And then we can have any number of machines and any number of agents running on each machine. When you do set up an agent, you do need to consider the purpose of it. It must support the job that you have in the stage of the pipeline. But notice in this example that you can only have self-hosted agents if you're going to deploy on premises. Because the pipelines run in the cloud, they need to be able to trigger self-hosted agents behind your firewall because they are going to be the only agents that have access to your environment on premises. So that means you must set up those self-hosted agents and then set up the communication with your pipeline. Anything running in the cloud, especially within Azure, could always be using Microsoft hosted agents as well as self-hosted agents also running in the cloud. When you have these agents executing in the cloud, they are going to be dependent on another feature within a DevOps, Azure DevOps, called parallel jobs. Parallel jobs are actually how many of these activities and jobs can run simultaneously, hence parallel. You have to purchase parallel jobs. Now you get one free, and it also depends on the type of subscription you have as to how many you may use at the same time. If you only use one, then you're going to have a bottleneck in when things can run because you may have 3 or 4 pipelines starting up, but they're not all going to run simultaneously unless you have enough parallel jobs to support it. In this example, we see that we have the numbers 1, 2, 3, and 4. 1 is a CI, continuous integration build pipeline, and then when it gets finished, then number 2 can start. But number 2 has within it a manual approval where it's waiting on a user. And that's what this symbol is right here. A person has to approve for it to continue. So it goes into a wait state. So anytime a parallel job goes into a wait state, it stops and another job can start up. So number 3 is where a job tried to start. It couldn't because there were no parallel jobs. So it went into a wait state. So as soon as number 2 went into a wait state, number 3 took off, and that's what number 4 is indicating, that now it's running. And then once the approval happened, step 5 indicates, says, oh, now we can continue. But we can't because number 4 is running. So when number 4 finishes, then this can continue up in here. So basically, they're taking turns. It's like having a one-lane road. Only one car can get on it at once. So the more parallel jobs that you purchase, the more you can have things running simultaneously. And so that's one of the costs of Azure DevOps, is to determine how many parallel jobs you're going to need. Now, there's two ways to build pipelines. We have the original visual designer, which seems to be, the best approach. However, this is considered classic pipelines. And notice here that you'd have to edit the code. You can push the code to repo, which in turn could trigger a continuous integration. Once the continuous integration is complete, it can create an artifact, which in turn triggers continuous deployment and deploys it to the target. That's the classic traditional way, and still can be done, but considered classic. What's missing here is we don't have any code that defines the continuous integration pipeline. When it says push to code, that's the code that's being used to create the artifact. But if we also define the pipelines with code using YAML, then it eliminates that graphical need, and everything is done through code. So both the edit code you see on the left, the YAML code also gets included with the repo, and so all of your pipelines are defined with YAML. And so your code is going to also include the definition of the pipelines. This is the preferred way of creating pipelines now in Azure DevOps. So continuous integration is our first process to help build and test your code. So you create pipelines for CI. This encourages sharing code and unit testing, and of course also pull requests, so that we can continue to merge it into yet another branch. This allows for automatic building. Every time a developer commits their code to a branch that has automatic triggering built in, it'll automatically build and test the code. And then everyone will know whether that build passed or not. Keeps the main branch clean. It improves code quality. It's automatic, it can be automatic. It reduces build times. You get feedback for every build. It also helps you address technical debt in a regular fashion. It also helps eliminate bug-inducing merges because you're doing it more often and with less code, hopefully building confidence in the code base, and gives you very quick feedback to the developer and the team, especially if the builds are published for everyone to see. You can also have what are called multi-job builds. If you break your pipeline into sections or stages, every one of those individual jobs may require different agents running on different machines that they in turn may be able to run in parallel, depending on parallel jobs. And then you can configure exactly how many different sections or stages you want, each with multiple jobs, and you can build faster uh, artifacts if you have multiple jobs in a single build. So the pipelines are made up of stages. Every stage is made up of job. Jobs are made up of steps, and steps are the individual or made up the task. We saw that in the diagram earlier. So with that in mind, here is an example of YAML code. YAML basically, instead of being visual, is breaking things down into this terminology where you have a pipeline. Any number of pipelines can also be associated with a single pipeline. They can also be containers. Here's an example of one that's triggered, and it's triggered based off of the main branch, any release that's going to trigger the execution of the pipeline. So YAML resources is allowing you to incorporate other areas within your YAML pipeline. Another thing to consider is Docker containers. Why do we want to use Docker containers? Well, it's a natural fit for microservices is one reason, but it also lets you define smaller and smaller components and have them run independently of each other in a particular environment. This is revolutionizing really how we write software and deploy software going forward. Why is it so popular? Is because it eliminates some of the needs we had in the past with virtual machines. With virtual machines, you must have an operating system in every VM. So as you see here, every one of these have an OS. But in containers, you don't. You only have to have the hosting operating system. So eliminating the operating system per VM makes a much smaller footprint. They're still isolated, and you can run many more containers in the same environment as you would just individual VMs because of eliminating the need for the OS inside each image. There's no need for the hypervisor, so the container engine is the only thing that's required, and in Microsoft, this is the Docker container engine. So with Docker, it's a separate technology, but Microsoft has fully incorporated it so that you can work with your Docker files to build, pull from registries, and run your Docker image in different environments. Microsoft has many different container-related services, so you can deploy to container instances, Kubernetes. You can register your image in Container Registry, and then you can also use a very new service called Container Apps that is an abstraction over Kubernetes, or you can run it in App Services, particularly if it's a web app or a web API. So containers are being heavily uh, uh, used by many different development teams, and also supported in Microsoft in many different ways. Which brings us to the second half of this type of process, and that's continuous delivery. This is releasing and deploying the changes to an environment. So these also must be repeatable, they must be reliable, and even the definition of these pipelines are also in source control. In fact, this is also where you would put infrastructure as code so that you could destroy and recreate the target environments. We want to automate everything if possible, uh, try to eliminate any manual steps. And this is when we define what done means, is when it does get released. If it's being deployed to your customers, they can see the value, then you can say it's really been done. Continuous delivery also needs to be continuously improved, always getting feedback, trying to figure out how we can make this better and faster with each iteration. We also want to keep in mind that release is not always the same as deployment. You could be deploying code constantly, but the end user doesn't see any difference yet because the feature is not complete. A functional release is when that feature is exposed and visible and functional to the customer. Everything up until that point could be deployment of code that will eventually support that feature. Well, all we're doing is deploying code that's for functionality, visible or not. In fact, it could be something that's behind the scenes that the customer never really sees, but we still could be deploying code at least sprint by sprint. There's also a difference between the release process and the release. The release process is basically the pipeline. It is all the steps required to get one or more artifacts to a destination. A release is what it's comprised of. It has the different sets of artifacts. The release is the artifact or artifacts that the release process deployed. So you have to be careful how you use these terms, and you can have multiple releases within one release pipeline because you could be deploying to multiple targets, different combinations of artifacts, and each of them being considered a different release, but all within the same process or the same pipeline. Which brings us to, where do we get these artifacts? Well, they could be output from a continuous integration pipeline. They could be predefined in a third-party repository. They could be within your own ACI, which is Azure Container Instances. That's the container repositories. Or they could be in your source control as like Azure repos. You need artifacts to deploy. So when you're designing your release pipelines, you'll notice that on the left, we do have, well, where are we going to get these artifacts? Well, it could be from a build or a CI pipeline, or it could be something that's just in source control that does not have to be built, or it could be any other number of sources. But notice on the right is where are we going to deliver it to? Dev, QA, and production indicate different environments. So could be done in series, or they could be done in parallel. And this shows you that we're really targeting 3 different environments with our release pipeline. What is a stage? Well, depending on the tool, sometimes you'll see stages and environments interchangeable, such as when we talk about dev, QA, and or testing and production. They could be environments that are very short-lived, such as dev or QA, or it could be long-lived like production. So when we think of the target, we have to always consider, well, what is that environment that we're trying to push something to? We have build and release tasks. So regardless of which type of pipeline we're building, we have unique tasks for each one. So a CI pipeline is going to have mostly build task, and our CD pipeline is going to have release task. But as you can see here, they're just listed as tasks for any pipeline. It's really the purpose of the pipeline that you're building. There are many other uh, actions that you could perform. So we have available to you in Azure DevOps Marketplace many different other things that you could include within your pipeline. So we could work with variables, we could work with other environments. As you see here, Sonar Cube, for example, could be introduced, delivery plans, Docker integration. Take advantage of the Azure DevOps Marketplace, especially if you have certain products that you're trying to interact with your pipelines. Then when we are ready to create a release pipeline, then we need to define the release jobs of what's in those pipelines, such as what are we going to target? Is it going to be .NET servers? Is it going to be iOS? Is it going to be Angular front end? Is it going to run on Linux? So those are the different tasks that we can pull into our jobs, which depend on agents, which run in stages, which are part of a pipeline. So a pipeline can get rather complex, depending on how many different jobs and stages you're trying to accomplish in a single pipeline. And within the pipelines, we do need to introduce checkpoints. Is it okay to continue? These are called release gates or quality gates. You may be checking for maybe even a work item, a bug or critical issue has come up. We need to maybe look for quality, a certain level of quality. We need to scan the artifacts that we're pulling in from some feed or what was built by a CI pipeline. We may have certain changes that may need to be incorporated first so it can stop existing pipelines. Or there could be just a problem with the infrastructure. The target environment may not even be there. So we need to use release gates to protect the quality of what we're deploying. No blocking issues, no license violations, no security vulnerabilities, no new technical debt. Now notice that's worded a little differently. There's always technical debt, but we want to be very careful of how much we're introducing. Are we in compliance with what needs to be done? On and on and on. This list will grow over time as you discover where there's issues with quality, and they can be added into your pipeline to check. And then we also have another feature in Azure called load testing. Azure load testing allows you to create a high-scale load once you've deployed it to a target environment, see if it can handle the load. So maybe not in dev, but maybe in QA and staging, you might want to test that. Maybe even production, but be careful you're not testing production and affecting current business activity. So what are some steps we need to consider? Well, you need to initialize the target environment for anything that needs to be done, at least, let's say, configuration settings. Deploy the update. You may also need to consider routing traffic to the updated version, especially if it's not in production yet. Test it, and then maybe redirect the traffic or redeploy. And if anything goes wrong, always have a way to back out of it. You need to restore to the last known good version, regardless of what environment you're targeting. You can also set up DevOps for notification. When something reaches a certain stage or something has been accomplished or pull requests are happening, builds are failing, releases are working or failing, set up notifications. Let you know when things are going on. At the same time, though, be very careful you don't create noise. Too much notification, people start ignoring it. but you do need to be aware of critical or problems that need to be addressed. So DevOps has built-in notification for that purpose. Take advantage of it. Another interesting area too within DevOps is documentation and release notes. Many times documentation and even release notes are a second thought, and we got to figure out how do we do this and end up creating more of a manual process. But you could put release notes directly within a feature, a work item. So notice in this example, it's highlighted in red. Here's the release notes about a feature called shopping cart should be personalized. All those release notes could be accumulated and published to a website or a wiki or something. So there's support for that also in Azure DevOps. So if we go back to the classical or traditional way of deployment, dev, test, staging, and production, you would treat those as individual environments in your CD pipeline. So you may want to automatically deploy to dev so every developer can see what's being done, but not necessarily to test, staging, and definitely not production until there's more quality checks or there's approval built in along each of these phases. This could be in one pipeline, or it could be 4 separate pipelines. When we consider deployment, there are different types of patterns that you could follow. Blue, green, canary, dark launching, and we're about to see each one of these. Blue-green means I'm going to deploy into production 2 different versions, and we're going to let some people look at the new versus continuing with the old. So blue is considered what is currently in production. Green is what we're trying to introduce, giving the opportunity for the user maybe to choose, or at some point we swap between the two to see if it's acceptable or not. Canary means we're going to target a very few number of people that are willing to take the risk of the system not working. So we want to only give canary releases to people who realize that this may not work. And only if they survive or, you know, sing its praises, then you can move on to the next phase. Canary releases are usually incorporated with other types of deployment, such as gradual deployment or ring deployment. They are the very first ones you want to try something out. So keep track of who those users are, because not all users are comfortable working with a canary release. Now, dark launching means you're only going to target a few people, but you're not going to tell them. They're going to be in the dark. And it's usually for testing the back end of a system that is not seen by the user. So they're not necessarily aware of any changes, but you're hoping to see if it's a much better response or faster processing, something that is not that obvious to them, but it could be a better experience overall because it could be much faster. Like switching out a back-end database or changing security or something that doesn't necessarily affect them directly. Because if it doesn't affect them directly, why do we need to tell them about things that they're not going to even be aware of? So dark launching has its place. We also have another one called A/B testing, where we deploy 2 different versions of the same in production. Now, this is different than blue-green. This is intended that we don't know which one is going to win out. We don't know what's better. This could be cosmetic changes or rearrangement, and we test to see, well, which ones do the users respond to better, whether it's higher use or they give their preference as to which one. And so we keep one and get rid of the other. It's an experiment between 2 variants of the same system. And then we have what's ring-based or gradual progressive deployment. Notice where canary sits here. It would be the first group. And for very large deployments, this is where we need to create multiple rings around who gets it. So canaries get it first. If it's okay by them, then we send it to early adopters, which is a bigger group, and then ultimately to our full user base. Now, large companies that produce, applications that are used by millions of people definitely need ring-based deployment. So depending on your customer base, this might be something to consider. And then we have a concept called feature toggles. Feature toggles allow you or the user to turn an entire feature on or off at once with a single switch. This requires no new deployment. Basically, it is a release when they're ready for it. It may be switching back and forth between A/B testing. It may be that a certain time in the future it needs to be tried, or it may be a certain limited number of people. But regardless of what you're tying it to, it has to be coded so that your code is checking every time it processes, is the feature on or off? Is it on or off? So this requires a lot of extra code, which in turn creates technical debt deliberately. So when you work with feature flags and feature toggles, you need to indicate in your code everywhere that this is a temporary block of code that we need to remove once the feature has been fully accepted. This can be very useful in features that may take a long time to activate, or we're giving the user the ability to turn it off and on. Not every feature should be handled that way. Now, Azure offers another service called App Configuration that you can use in DevOps that allows you to centrally control not only the configuration of the app, but also those feature flags. We can set up different configuration settings with key value pairs, such as connection strings. In dev, we connect to this database, but in production, we connect to this database. Or in this version, we want something to be blue, we want this one to be green. It could be just basic ways of indicating different versions of an application. This is wide open, however many key value pairs you want to use. And then your code is referencing these settings that are external. So we can store different values for particular keys and environments in a centralized state. And then with feature flags, we can turn on and off features across multiple apps. So instead of having just feature flags defined per app, they can be centralized in app config, and we can refer to those features. And the features can be in a hierarchy. We have features that are made up of other features, and every one of them can be turned on and off per application. This can be very handy for a broad application of features across multiple apps. And of course, we've got secrets that we need to be careful of. We never want to hard code secrets in our pipelines. We want to make sure that no script, no code has secrets, keys, and certificates directly in our source code. Never, and it should be in nowhere. So what we have available to you is Azure Key Vault. Azure Key Vault is another service that allows you to store secrets and certificates and keys and control access to those secrets through security in Azure. So this is one area that you can allow your pipelines to connect to get a secret so that they can apply it in a certain environment that needs it. Everything from encryption to authentication. So this lets you centralize your secrets. It gives you control over who will have access to it and monitors who and what applications have access to it. This is an ideal place to centralize your keys for any service, not just pipelines. Which brings us to the concept of imperative and declarative configuration. Imperative usually means that we have defined how something should achieve a certain state. The best approach, though, is declarative in most cases. What is that final state? When you use declarative, you use things such as templates to define what is the end result that we want, which allows the system to reach that state without being told how to do it. Imperative means you must follow a certain set of steps. You're basically trying to control how something happens to get to that final state. So you're kind of holding its hand all the way through. So when we're coding things like through PowerShell and Azure CLI, we're telling it exactly how we want something done. That is not always necessary. If we just tell it what we want in the end, then that allows Azure or someone to follow whatever steps they want to get to that final result. So declarative is usually much more efficient, but you can't say that in every case. So you need to know that declarative just says what we want it to be. Imperative is how we want it to be done. You can mix the two, or you can commit to using one or the other. So with templates, it's declarative. This is much faster and more repeatable, and it supports parallel processing. So templates are the preferred way of defining how your environment should be set up for pipelines. So whether you use ARM templates or also what's called bicep templates, you can define exactly what you want, and this is how you can treat your infrastructure as code, as defining everything as a template. These are written in JSON. They also have key value pairs in a JSON format, and they're made up of parameters, variables, functions, resources, and outputs. You don't need all of these, but the main reason of using them is for resources. So 90% usually of a template is defining resources. Making them more flexible usually incorporates parameters and variables. Your templates can also use the key vault. Instead of storing secrets directly within the templates, you can have what's called a parameter file that points over to a key vault to get the values needed for your pipelines. And then speaking of imperative, we have scripting, whether it's CLI or PowerShell or both. You're basically giving very specific commands of how something should be done. Now, to mix the two, like I said earlier, you could use Azure CLI or PowerShell to deploy a template. And then the template takes over, and then from that point on, it's declarative and allows Azure to run things in any order and in parallel to get it done as quickly as possible. Try to avoid scripting, especially when you're trying to define your infrastructure. Try to lean more toward templates, whether they're ARM templates or bicep templates. Which brings us to security. Security should be thought of from day one, from immediately, and should always be part of your team discussion. And security in DevOps comes into play at the very beginning. We want to make sure whatever infrastructure we create for our targets is the most secured infrastructure. We want to layer that security, make sure that we're handling authentication and authorization correctly, and always continuously validating if security is correct every time we deploy to a new environment, and monitoring for attacks. Which brings us to another term that if we include security within this this term DevOps, sometimes you see it referred to as DevSecOps, because it's not just development, it's not just operations, but it's also security needs to be incorporated. So it uses the same practices that we may think of as separate from DevOps as part of the overall process. So it allows us to create a security strategy, everything from access control to environment hardening to make sure it's tight and secure as possible, and perimeter protection such as for networks. This needs to be tested at many different points, but tying it back to the terms we've already talked about, we need things to check security and check vulnerability either within the applications we're writing in, such as the IDE that's mentioned here, Visual Studio, Visual Studio Code, and any other tool we may be using. It should also be included in our CI pipelines, check for vulnerability of different codes or components we're introducing. We also need in dev passive pen test. That means penetrative testing, SSL scanner, encryption, etc. And then testing and also within staging, scanning your infrastructure, looking for known potential vulnerabilities with security. And there are many third-party tools that allow you to do that. Pay attention to every one of these need to be tied to feedback. Notice how all these lines come back to feedback so that you can get reports on the state of security within your from within your pipelines. We need to do this to save money. Notice here this is another term we call shift left. Shift left is to go exactly on this slide, look to the left, and try to address the defects as early as possible. The cheapest and the best time to locate defects would be at coding stage. The developer themselves need to discover problems, not just bugs in logic, but security issues, security potential validations. If we wait too long, we don't pick it up until the CI pipeline. That's the build. Notice it's going to cost roughly 3 times as much, from 80 to 240. And if we don't catch it in the build, then we may have to catch it in another pipeline or another target when we try to push it out to QA. But especially if we wait to production, it's going to have a much broader effect and may cause much higher potential damage, but also cost a lot more to fix because we got to go back to the very beginning anyway to fix these problems. So just like with bugs, we want to validate security as early and as soon as possible. We're also going to be incorporating other packages and libraries that are considered open source. Most of our software today is made up of open source to some degree. From 10 to 80% of software we build is built on other software. So we need to be careful about what we incorporate and also the type of licensing that we are using. Be sure to introduce other third-party tools that can check your package security and license rate. Some of those tools are mentioned here: Artifactory, SonarQube, and MinBolt. Definitely investigate those as to something to include within your pipelines. Our software is very dependent on other components because software is very complex. Nobody sits down and writes one application all by themselves. They're introducing many other components. These will be packages that could be written in for any one of these combinations, whether it's .NET or JavaScript or Java or anything else, or Python. We are going to be pulling in packages from many different sources. So we are going to be pulling things from package feeds. How can we trust those package feeds? How do we work with them? Well, this is yet another area within Azure DevOps called artifacts. Azure Artifacts works with different package feeds to bring those into the scope of your project or for you to record your own artifacts within these different categories. So an artifact itself is a deployable component. Whether you built the artifact or you pulled the artifact from a public feed, it allows you to incorporate them in your environment and to include them in pipelines as needed, so that we don't have to manage any file shares. We don't have to host package servers somewhere else. We can incorporate them right in Azure Artifacts in any one of those categories. These packages will be versioned when they come from third parties, but when you create your own, you also need to consider versioning your own packages to be used within artifacts. Once a package is put into Azure Artifacts, it will have different views. Immediately when it's put in there, right out of the box, it's called local. Now, local packages do not show up for anyone else, so they don't automatically incorporate them within their coding solution. They have to be moved to one of these different views. So as you test and see that, okay, this package is all right, then we might move it to pre-release. And then that gives the developer the opportunity, well, they may want to use it or not, but when you finally move it to release, that means you fully tested it and you're saying that it can be used now within code. This can be done for packages you create or public packages that you bring into your environment. And then you can also use the interface to do this. And notice what's highlighted here is a promote option. So you promote something from local to the different stages depending on when you say it's available to be used within your pipelines. Now, whatever you do, make sure you're monitoring what you're doing. This is a point of feedback. So we've looked at all the different major features. So we need to also look at other Azure capabilities to keep track of what we're doing with DevOps, monitoring the infrastructure, the app, and any type of logging that's been performed. So Azure includes something called Azure Monitor. It primarily is keeping track of metrics and logs for many different purposes. And on the right, you can see at the top that we can get insights from the applications, from containers, from virtual machines, and we can access the metrics and the logs there in the center with multiple types of capabilities, including Power BI for that matter. To access the logs, you need to learn a language called KQL, Kusto Query Language. It's similar to SQL, but actually even simpler than SQL, that allows you to query the logs that Microsoft is gathering for all of your applications and virtual machines, and you can consolidate them into one place and query your logs to find out what's going on. You also can use what's called the Azure Data Explorer and the Data Studio to read those logs in order to access the information that's in log analytics. You can also use something called application insights. In this diagram, AI does not stand for artificial intelligence. I want to make sure that's clear. It stands for application insights. So regardless of where your application is running, it could be on premises, it could be in Azure, it could be over in AWS from Amazon. It could run anywhere. But if you deploy an AI agent, an application insight agent into your application, it can send periodically information back to a central location in the cloud called application insights. It's gathering all the information about particularly web apps is what it does really well at. And then you can look at that information either through Visual Studio, which it's incorporated directly, through Power BI, you can set up alerts, etc., within the cloud. Great time to do this is when you're considering making changes to a legacy app. Maybe you should stop and put App Insight agents in that legacy app first to see how it behaves, and then you can have a better idea of maybe some of the changes you might make. So what is Azure DevOps? Well, we've covered the highlights here: boards, pipelines, repos, artifacts, and test plans. We did not go into test plans, but I want to make sure that that is presented to you so that you can take opportunity at some point to explore how do we set up test plans. But the main focus was in these first four, and I hope you got a lot out of that. That is a really heavy introduction really to these concepts, but hopefully it'll spark some interest into looking into other courses about Azure DevOps. So what's your next step? Keep learning, get certified. What we just covered is in the AZ400 course at a much more slower and deliberate pace, but we cover all of those topics within that course. To be certified will also cause you to stand out. You'll get better recognition. You'll be more confident about a subject. You will have covered all of the major areas of that particular product. So no guessing to say, oh, is there anything else I need to know about this particular role or this product? Well, the certification test will do a thorough coverage of really everything you need to know about a particular role or service offered by Microsoft. Once you're certified, then you can, of course, publish it out to LinkedIn, Facebook, Twitter, etc. As you are being certified and as you go through other courses, even if they're free online courses, you do get badges for it. So badges are separate than just certification. You do get a badge for certification, but you can also get badges for covering content within Microsoft learning sites. Let the data speak. There is a book that's available from Netcom, The Win-Win of Certification. And you should have a link for that included within your invitation or for this course. And notice here, well-trained and certified teams are 20% more productive than other staff, or almost 20% more productive. So of course, with training, we should be more productive, but with certification too, we know we've covered the main points of a particular service or product. Grow your business and career. Look at the role-based training that's available to you. As you move through each area, some of the courses will be fundamental. Anything with a number 900 usually are all the fundamentals like AZ 900, AI 900, DP 900, and they don't require a retake, or I shouldn't say retake. They don't require an update later. They're permanent. But the others, associate, expert, specialty, they do require certification, but within a year or two, you also need to get caught up on what may have come out since the original certification. Now, the first certification exam is proctored. So it's closed book. You have to answer questions within a limited amount of time. The follow-up exams for the same topic are not proctored. You don't have a time limit, and it's open book, and you can look up answers to every question. So it makes it much easier to keep your certifications current. Role-based instructor-led classroom training is ideal. You'll get one-on-one conversations with the instructor. You'll get real world cases and business context, and you can ask the certified trainers directly any questions. You have 6 months access to the virtual labs that are set up, and you'll also have recordings of the classes you can come back to and review. So those are an excellent way to get direct learning from an instructor, certified instructor, on these topics. And notice too, you have free repeats as an auditor, and priority support for helping you with the class. Even after the class is over and you want to work with the virtual labs for months later, you'll have access to that, the support for it. Oh, this is what I was just talking about, renewals. Some of the certifications do require renewals, but they're much easier to renew, which will let you know that. You don't have to pay or pass any proctored exams, but you do have to pass questions by looking up the answers. So it just prompts you in the direction you need to go to keep up to date. So you pass an assessment test before the certification expires. You cannot actually do the assessment after it expires. You have to start all over again. Now you're given a heads up as when it's about to expire, 6 months prior to your first notice, and then every month after that to remind you, hey, you need to stop and go through this assessment test in order to keep your certification alive. So let's get trained and certified. Whatever your interest is, whatever your direction you know you need to take, follow that path, stick to it, take the courses, whether they're free online or instructor-led. Of course, I would prefer you take the instructor-led, and I would love to teach you any of these topics. So ask for me and ask for the AZ400 to get more deliberate and hands-on and personal training on the subject that we just discussed. And thank you. Thank you for attending this webinar. I look forward to seeing you in a class for any of these topics.
Thank you, Tom. That was most informative. I know everyone is looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And while you do that, I would like to give the presentation rights over to Sagnik, our vendor manager, to introduce you to our promotions and webinar-related courses.
Thanks, Tracy. So first of all, I'd like to thank everyone for joining us today for this insightful session. And on my screen, you can see a landing page. The purpose of this landing page is to allow all of us to go through some exclusive benefits that we are providing to all our learners. Every participant in today's masterclass have been given exclusive free access to the AZ900 and AZ400 courseware. And the best part is you also get to claim your digital achievement badges on Microsoft Learn to celebrate your Azure skilling journey. Issued by Microsoft, these badges can help you to highlight your newly acquired skills and boost your career potential. So all you need to do is follow the link that is being shared on your chat window or is available within your event handout, and you'd be redirected to this particular page, as you can see on my screen. On this section, you'd find that as part of this benefit, you are getting the courseware access to AZ900, Microsoft Azure Fundamentals, and AZ400. The topic of today's masterclass was kind of covering the designing and implementing Microsoft DevOps solutions. And as I mentioned, you'd also be getting digital achievement badges and trophies from Microsoft. So you have to find 2 links over here. You have to just click on these links and you'd be redirected to Microsoft Learn and follow the steps to redeem. It's the process is very simple and it has been demonstrated in the section below. So as you can currently see on my screen, if I scroll down a little bit, there are 3 steps that you need to follow to redeem your courseware and badges. The step 1 kind of remains the same for both of these steps, for both of these courseware and badges on AZ900 and AZ400. First and foremost, you need to make sure you're signed into your Microsoft Learn account using your personal or professional Outlook or Hotmail ID. Once you're signed in, It will, if you're already signed in, it's going to directly load into your profile and you're going to be seeing the redemption screen, which is part of step 2. If not, you'd be greeted with this particular prompt asking you to sign in. If you have an account, please enter those credentials. If you don't, you can click on the create one option, which has been highlighted over here. If you don't have an existing Microsoft account, you can use the link here to create your profile. And then you can come back to this page and then click on these buttons, and then you would be able to follow through with the rest of the process. As step 2, once you're logged in, you'd be greeted with this prompt wherein a unique code will be automatically populated into this field. You don't have to put in any code manually. You just have to use the links that have been provided here. And all you need to do at this step is just click on this redeem option that has been highlighted in the red box. Once you're done with that, you're going to get a prompt like this within a few seconds, confirming that your achievements have been successfully added to your profile. So since we are providing 2 badges and courseware with this particular masterclass, you have to repeat this process twice. So you have this page, you open this page, every link is going to be opening on a separate new tab. So we have got you covered. All you need to do is first complete the process using your AZ900. And since you're already logged in, you just have to switch the tab and click on this particular link. And again, the second courseware will be redeemed instantly. In order to access your courseware, you can find the training modules under the training tab within your Microsoft Learn profile. Make sure to explore those resources and take full advantage of your Microsoft Azure skilling journey. And be sure to be proud of your achievements and celebrate it by sharing your digital trophies on your LinkedIn profile. And don't forget to tag Netcom Learning and Microsoft on your posts for maximum visibility and reach. Moving on, we're going to take a look at the handout that we have. So as you can see on my screen, this is the event handout that you all have received. Once again, we thank you all for taking out the time and joining our masterclass today. As part of this handout, you'd see the content section wherein the different sections within the document have been listed here, and everything is hyperlinked. So you can quickly use these links to jump to the specific section of the document. Before we proceed, it's worth mentioning that Netcom Learning, we are the proud winners of the Microsoft Partner of the Year Award for 2 years in a row. So as we say, the legacy continues. In 2022, we were the Partner of the Year worldwide, and in 2023, we were the Partner of the Year for United States. And we are also a Microsoft Cloud Solutions partner. That means that we have capabilities across all the 6 solution areas recognized by Microsoft. A few more things about us. We are in the training industry for over 25 years now, having serviced over 80% of the Fortune 1000 companies, serviced 100 plus US military bases. Overall, we have trained 1 million plus professionals across 36,000 plus unique enterprises, and we enjoy a 96% recommendation rate from our customers. All our trainings on Microsoft are delivered by instructors that are certified and authorized by Microsoft. And our overall instructor pool stands at about 3,200 plus certified professionals. We are your one-stop solution for all your corporate upskilling needs with official training across every major technology and business solution provider. So as we can see over here, we are an authorized training partner for all the industry leaders across Microsoft, AWS, Cisco, CompTIA, PMI, EC Council, and others. Now, within this handout, you would also find this particular page wherein you can find the session recording. You can use the link to access the recording for today's session and revisit the concepts that were covered in today's masterclass. On this page, you'd find the link to access your complimentary courseware and the digital badges. The same landing page that we covered at the beginning of my presentation. You can find the direct access link here, and the link to which is also available on your chat on GoToWebinar. Also, all the participants will be given access to Netcom 365. It is our student portal that includes a lot of features and resources for you to take advantage of to supercharge your skilling journey. All you need to do if you're accessing it and activating it for the first time is set up your password and then you'd be good to go. We highly recommend everyone to explore our learning portal uh, to take full advantage of all your skilling resources. Now let's quickly take a look at some of the latest offers on Microsoft trainings and certifications. First up, we have the Microsoft Quick Start program, which is applicable across the entire portfolio, encompassing Azure, Security, Microsoft 365, Dynamics 365, and Power Platform. It is truly the best in class exclusive enterprise discount offering on your end-to-end Microsoft training across the official portfolio. The pricing model is quite simple and straightforward. If you have a team, if whether you are a large organization or a small organization, and you have a team to train across departments or within the same department, we have two options for you depending on your team size. If you are looking to train more than 15 learners, you would be getting a flat discounted pricing of $300 per day per learner. And of course, as the number of days for the particular training increases, the amount also increases, but you get significant savings on this. If you are having a smaller team that is 14 learners or less, then you still are entitled to a $400 discounted flat pricing per day per learner. This really accounts to huge savings when it comes to large scale training. So we highly recommend everyone to get in touch with us, explore the offering by clicking on the link provided in this handout. And all your trainings can also be customized based on the specific projects and workloads that you and your team, your organization is working on. And our industry specific subject matter expertise encompasses a wide range of verticals, as you can see over here, from banking and financial services, healthcare, federal and state and local government, to education, energy, manufacturing, retail, consumer goods, and more. Next up, we have the Microsoft value of certification. Uh, we highly recommend, along with Microsoft, that whenever you're investing in your skilling journey, be it in terms of your time and effort or your training funds, it's always recommended to secure your skills by getting the validation and approval from Microsoft. So what it does is certification from a decision maker perspective. You want to ensure that the ROI on the training is guaranteed. So this is like a quality control on the training investments that you make for your team. So once your team completes the skilling, they can take the associated certification exam to make sure that they are eligible and they qualify under the standards that have been set by Microsoft on the related technologies. And if you are a learner and a professional, it is a great career booster for you, right? The credential of being Microsoft certified is industry recognized, and these are industry aligned to specific job roles, and these demonstrate the real world skills required to solve real world business challenges. So these badges add a lot of value to the credibility of your profile. It enhances your job prospects and career growth. For a limited time, we have a 10% exclusive discount on all Microsoft certification exam vouchers going on right now. We highly recommend if you are considering taking training or getting certified, this is the right time for you to do so. The link has been provided on this particular page of your handout. We highly recommend you to avail the same. Also, you'd find that if you have a team, if you are a big organization or a small organization, having a team that you're looking to train, our 2-hour private group training demo is also a great option for you as the next step. It is free of cost, as we say, you can see over here, and it is customizable as per your needs. So rather than a public delivery, which was the format of today's session, you're going to get a private group training wherein our instructor is going to connect with you understand your specific requirements, and our learning consultants are going to map out your specific needs and accordingly tailor the skilling plan that makes sense for you and your business. So these training demos are provide a great value because these are customizable. All the trainings are delivered by our top rated trainers, and you get a complimentary skilling plan consultation, allowing you to get clarity on which specific courses are needed to be taken by your team. And in case you are a large organization, you are a multi-shore firm with multiple divisions and your workforce spread across geographies, or you have multiple business units within the same organization, the skilling needs kind of get complicated in those scenarios, right? But how do you manage your training funds in that case? And that's why we have the Learning Passport, which provides a flexible team training package. Basically, you park all your training funds with us for 12 months. And within these 12 months, you get exceptional value on the funds that you invest, right? Up to 100% increase of your fund value is what you can experience with our Learning Passport. And these funds are flexible. That means you can use it to train irrespective of the individual that you want to opt in for. A simple distinction with the Netcom Plus is that it is mapped to the specific learner and it is only valid for that learner. But in Learning Passport, you get that additional flexibility that for one particular course, you can pick one particular learner, and for another, you can use your same training dollars for another course. This is basically giving you unlimited access to our entire authorized training portfolio of 4,000 plus official courses. So we highly recommend you to check this out if you have such skilling requirements, especially keeping in mind that the end of the year is coming and we are aware that organizations need to finalize their training budgets. If they don't use it, they kind of lose it. So this is an ideal solution for you guys to park your training funds and make sure you get the ultimate value all year round. Now we will take a look at the recommended courses that we have. Over here, you can see the courses that are related to today's topic have been mapped here, divided by fundamentals and role-based. So we highly recommend everyone to click on these links. All of these are hyperlinked. Pick the item that you want to explore and you'd be redirected to the official documentation that we have on these particular courses. Also, please note that all the courses that are delivered by Netcom Learning are delivered by subject matter experts. You get additional perks like 180 days access to virtual labs wherever applicable. Also, you get access to 90 days to the class recordings to revisit the concepts. You get full access to our Netcom 365 portal, as well as you can repeat the classes free of cost within a specified duration if you want to revisit or you couldn't attend the first time. We also have a couple of free resources mapped here, like our upcoming free event and a blog. We highly recommend you to explore those as well. With that, I'd like to thank everyone. Do follow us on our social handles, and we hope to see you soon once again on one of our events and classes. Thank you, everyone. Over to you, Trace.
Thanks so much for guiding us through that information, Sagnik. And now we're going to go ahead and jump right into our question and answer session. First question we have today is, do I have to use boards, repos, pipelines, and test plans when using Azure DevOps?
No, you can pick and choose whatever services you need. You can continue to use any third-party services, and most of them will incorporate directly back into DevOps. So they'll pick and choose what you want to use, but there is an advantage of using all of them because they're tightly integrated, but it's not required.
Our next question is, can you create just one pipeline to handle the full CI/CD process?
You can, but it's not encouraged at all, mainly because the CI pipelines will probably run far more often than CD pipelines, and they will fail more often because they're constantly testing new code that gets committed. So you want to keep your CI pipeline separate. You also want to keep a status of how many times it succeeds and how many times it fails. It's a good metric to keep in mind so that developers can see that their code is affecting the build, and that there may need to be a tighter integration of pull requests to make sure that your CI pipelines are finishing more often with success. Whereas only after a successful CI can you actually do a CD. And so the CD pipelines are expecting code to be fully tested, ready to go, and we're just focusing on the environments and the targets and running quality tests on the artifacts. So that's a second phase. They can be put together, but strongly discouraged, don't do that, because you're really targeting different audiences too for the outcome.
And let's take one last question before wrapping up today. Do you have to use all other Azure services to use Azure DevOps?
No, but you must have a tenant. You must have an Azure tenant, because otherwise you won't be able to even create a DevOps project. So first thing is you have to have the Azure tenant, which means also that you're given an Azure directory, which is part of Azure Intra ID, which is for security, for authentication. So that's it. That's actually the minimum requirements is you have to have an Azure subscription, and you also, of course, with that you get a directory or Entra ID for authentication. That's it. None of the other services are required, but they definitely complement DevOps. Particularly the Key Vault would be another one you might want to consider, but still it's not required.
Once again, I want to remind you that as you leave this session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience, as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.